Okay, class, today we're going to talk about solving two-step equations. What we've been working on is solving one-step equations. But first, let's kind of review. Well, what is an equation? Well, it's two expressions that are equal to each other. And in every equation that we do, we have a particular goal. So what is the goal in an equation? It is to solve for the variable or get the letter by itself. Okay? And in order to do that, we've got a few things that we've learned. Okay, so if it's an equation that involves addition, then we add the opposite. If it's one that involves subtraction, we change it to addition, and then we add the opposite. And if I add something to one side, I must add it to the other. If it's a multiply or divide problem, then to get rid of multiply, we do a divide. To get rid of a division, we do a multiply. So we do the opposite if it's multiply divide. Well, today what I want to look at is multi-step problems. What if it's got both add, subtract, and multiply divide in it? But before we do that, let's kind of review something. When you think of equations, basically what we're looking at is order of operations with a piece missing. And anytime we have a problem like this, what I really want to do is simplify it down to get an answer. Well, in an equation, I already have an answer. So really, all we do is take these kind of problems and work them backwards. So let's just see what would happen if I did one of these. Okay, and this is an order of operations problem. So, we start with the parentheses. So we write everything down except for the parenthesis line. So now we have this 5 minus 8 that I got to get an answer to. Well, we know 5 minus 8, I can't do that. So we change this because it's going to be a negative answer. And we end up with a negative 3. Because 5 plus negative 8, our signs are different, so we subtract and take the sign of the number with the greatest absolute value, which is the negative 8. Divide by 2. So now we're ready for exponents. So now we're going to do this one little exponent line right here. 3 to the second power means 3 times 3, which gives us 9. And then plus 4 times negative 3, divide by 2. Now we're ready for the multiply divide line, which means I'm going to do all of this right here all at one time. So we write the 9 plus down, and now we're going to do 4 times negative 3, which gives us negative 12, and immediately divide that by 2, which gives us a negative 6. Now we're ready for our add subtract. Well, our signs are different in this problem, so that means we're going to subtract. So 9 take away 6 is 3, which is the answer. Okay? So when we think about order of operations, we're simplifying this expression down to an answer. Well, in an equation, we already know the answer. It's just there's going to be one little spot missing, and that's what we're going to be looking for. Okay? So there was a specific order to solve that problem. You had to, 1, evaluate the parentheses, then the exponent, next the multiply and divide, and then lastly the addition. Okay? So when you see a problem like this, what we're going to do is we're going to reverse the order of operations. We're just going to turn it upside down. Okay, we're going to work it backwards until we get to this particular variable that we're looking for. So the first thing that we're going to do says with equations with more than one operation, you can solve using reverse order of operations. So we're going to start on the last thing that we did with order of operations, which is add, subtract. And we're going to try to get rid of that. Then we're going to move up the line and try to get rid of multiply and divide. Okay? So let's go back and look at this equation. 4h plus 3 equals negative 9. The first thing I want to get rid of is this plus 3. And we're going to do that by adding its opposite. So we're going to do 4h plus 3 plus negative 3, because that's the opposite. And if I add its opposite to one side, I have to add it to the other side as well. So I've got to make sure I have that on both sides. We've got to maintain balance in our equation. Just kind of imagine this has got a pan right here, and this is a pan, and here is our balance point, and it's balanced. So if I add one thing to this pan, I have to add the same thing over to this pan to maintain that balance. So now I simplify this expression. So these 3's go away. We're left with 4h. And then I simplify the other side. Negative 9 and negative 3 actually gives us negative 12. So we now got rid of the addition and subtraction. we now have a multiply divide problem. So how do I get rid of the multiply by 4? This says 4h's is equal to negative 12. I don't want to know about 4h's. I only want to know about one of them. So we divide by 4, divide the other side by 4, because what you do to one side, you must do to the other. These divide out. You're left with h, or 1h, equals, and then negative 12 divided by 4 gives us negative 3. And that's solving a two-step equation. So if I were to take this negative 3 and plug it back into the original problem, 4 times negative 3 plus 3, does that equal negative 9? Well, 4 times negative 3 gives us negative 12. And then negative 12 plus positive 3 does give us the negative 9. So it works. So let's try another one. 3x minus 5 equals 10. Well, in the other problems when we were doing this, if you saw minus, we immediately changed it to plus and the next to its opposite. Makes it just a little bit easier to work with. Plus, if you get your numbers out of order, it's not going to hurt you, because in addition, we do have the commutative property. So now I need to get rid of this negative 5, and I do that by adding its opposite. So we're going to do 3x plus negative 5 plus its opposite of positive 5 equals 10 plus, and now what did I add on this on the left-hand side? I added a positive 5 or a plus 5, so I need to do the same thing on the right-hand side. So now my 5's subtract out, and I'm left with 3x on the left of the equal sign, and then 10 plus 5 on the right, which gives me 15. Now again, it says I've got 3 x's, but I don't want to know about 3 x's. I want to know about only one of them. So I divide by 3, and if I divide one side by 3, I must divide the other by 3 as well, and you end up with x equaling 15 divided by 3 is 5. Now if we were to plug that back into the original equation, 3 times 5 minus 5, does that equal 10? Well, 3 times 5 is 15. That was a minus 5. Minus 5. Does that give me 10? Yes, it does. So it works. X equals 5 is the answer. So let's try one on your own. Okay, let's see how you did. 5t plus 12 plus negative 12 equals negative 18. What did I add on the other side? A negative 12, so plus negative 12. We end up with 5t equals negative 30. We divide both sides by 5, and t is equal to negative 6. So how'd you do? Did you get it right? I sure hope so. So what about division? Do we do that the same way? Yes, we do. We start by getting rid of this 6. So how do I do that? I add its opposite. So g divided by 4 plus 6 plus negative 6 equals negative 4 plus negative 6. So my 6's add out, and we're left with g divided by 4 is equal to negative 10. Now this says basically I've got 1/4 of a g. Well, 1/4 of a g is equal to negative 10, so what is a whole g worth? Well, to find that out, I just take this and I multiply it by 4, because now I've got a 4 in the denominator and a 4 in the numerator. So over here I multiply it by 4 as well. My 4's divide out, and I'm left with g equaling negative 10 times 4 gives me negative 40. Just like that. Well, let's try a couple more. There's a couple more little scenarios that I need you to see real quick. Okay, so this one, the letter's on the other side. Can I take this whole thing and flip it over here if you want to? Sure, you can. 4n plus 5 equals 21 is the same equation. And we would still do the same thing. We would get rid of this 5 by adding its opposite. Then we would get rid of this 4 and divide both sides by 4. Okay? So I'll just kind of sketch this one out real fast. Move this over. And this is what this one should look like if you have the letter on the right-hand side. You do 4n plus 5 plus negative 5. Then 21 plus negative 5. Notice I added the negative 5 on both sides. So we now simplify both sides. 21 plus negative 5 gives us 16 equals, on this side, my right-hand side, my 5's go away. You're left with 4n. It have a multiply by 4, so we do a divide by 4. Do a divide by 4 on the other side. And we end up with 4 equals n, or n equals 4. Now what if we have something like this? This one's kind of tricky. This one looks like it's a one-step problem, but it's really not. It's actually a two-step problem. Because what are we going to do right here? We're going to take this minus, we're going to change it to a plus, and that k becomes negative. So our goal is still to get the letter by itself. So that means I need to get rid of this 7. And to do that, I add its opposite. So we've got 7 plus negative 7. That gets rid of the 7 part. Plus negative k equals 15 plus the new part. What did I add? The negative 7. So we end up with negative k equals, and then we've got 7 or 15 plus negative 7, which means we're going to subtract those. And we should end up with a positive 8, because 8 and 7 make 15. Okay? Now, this negative k says negative k is equal to 8. Well, if negative k is equal to 8, then what do you think positive k would be equal to? Correct. It's going to be a negative 8. Because all we have to do when we end up with the negative letter, because this is essentially negative 1k. So how do I get rid of the negative 1? We divide both sides by negative 1. And we know that dividing 8 by 1 is not going to do anything, but it will if I divide by a negative 1, flip the sign. So all you really have to do when you see this situation right here is change this one to a positive, change this one to a negative. And we're done. So k is equal to negative 8. One last problem. What if I had a fraction, an actual fraction, something other than just x over 5 or something like that? Well, we still start with the same thing by getting rid of this plus 4. So we write 2/5 x plus 4, and to get rid of that 4, we add its opposite. And if I add that to one side, I have to add it to the other. So we end up with our 4's going away, and we're left with 2/5 x is equal to 10. Now, to get rid of a fraction, or to get that fraction turned to 1, what we've learned in the past is that if I multiply this fraction by its reciprocal, it will turn to 1. Well, the reciprocal of 2 over 5 is 5 over 2. Because now this 5 cancels out and turns to 1s. These 2's cancel out and turns to 1s. And we're left with x. But if I multiply this side by 5 over 2, I have to multiply this side by 5 over 2 as well. Now, in order to multiply a whole number times a fraction, I need to turn the whole number into a fraction. And we know we do that by putting a 1 on the bottom. Now, is there any simplifying we can do? Well, I can't do the 10 and the 5 because that's a top and a top. But I can do the 10 and the 2, which is a top and a bottom. And if I divide them both by 2, this number turns to a 5. This number turns to a 1. And now I'm left with 5 times 5 divided by 1 times 1, which we know is just 25. So multiplying with a fraction, it's no big deal. You just multiply by its reciprocal. So that's how we do two-step equations. We first get rid of add, subtract. Then we get rid of the multiply, divide. We just do everything in reverse order of operations.